Hello, this video is for textbook chapter 2 lesson 4. It is titled Solving Equations with Variables on Both Sides. The objective is to solve equations in one variable that contain variable terms on both sides of the equation. Our vocabulary for this lesson is identity. So why learn this? Because you can compare prices and find the best value. Many phone companies offer low rates for long-distance calls without requiring customers to sign up for their services. To compare rates, solve an equation with variables on both sides. To solve an equation like this, use inverse operations to collect variable terms on one side of the equation. So the idea, what they're talking about whenever they use the term collect, they're saying that we're going to want to get all of our variables over to one side of the equation. We're going to have a situation where we have variables on both sides of the equation, that is to say on both sides of the equal sign, and so we want to collect them, or I like to think of them as move them to one side as opposed to collecting. But textbook likes to use the word collect, and which is interesting because many of you may not be old enough to know about collect calls, but there used to be such thing as a collect call, where you would reverse the charges to the person you were calling instead of paying for them yourself. Let's look at the next page here. Example 1 of solving equations with variables on both sides. Solve an equation, or solve each equation. First equation we have is 7k equals 4k plus 15. Now you'll notice that we have the variable k on both sides of the equation. So they're saying to collect those variables on one side by subtracting 4k from both sides. Well, you might say, well, what about subtracting 7k from both sides instead of 4k? How do we know whether to subtract the 4k or to subtract the 7k? Well, let's go ahead and look at our helpful hint over here for a little bit of information on that. Equations are often easier to solve when the variable has a positive coefficient. That means that the number in front of the variable is a positive number as opposed to a negative number. Keep this in mind when deciding on which side to collect the variable terms, or as I like to say, which side you want to move the variable terms on, or which side you want to get the terms over to one side or the other. And so we'll kind of consider that as we decide whether or not to subtract 7k or subtract 4k. Now they're saying subtract 4k, and notice by doing that 7k minus 4k equals 3k, and 3 is a positive number, so that works out well. But what if we would have subtracted 7k? Well, 7k minus 7k would have been 0k over here, so we would have just had a 0 over here. And then 4 minus 7 would be negative 3. So we'd end up with a negative 3k plus 15, and then we would have had to subtract 15 from each side, and then we would have to go ahead and multiply or divide by negative 1, and we can avoid all that if we go ahead and keep our coefficient in front of the variables positive if possible. And we do that by determining which one we want to move from one side to the other so that we can go ahead and maintain positive coefficients in front of our variables. So we go ahead and subtract 4k from each side. We end up with 3k equals 15. Now we need to divide the 3k by 3 to get the k isolated by itself. So we're going to divide 3k by 3, and what we do to one side we do to the other. The 3's cancel, leaving us with k, and 15 divided by 3 is indeed 5, so k equals 5. In example B, we have 5x minus 2 equals 3x plus 4. So we need to collect, or that is to say move our variables over to one side or the other. Well, the question is, should we subtract 5k or should we subtract 3k? Well, if we take 3 away from 5, we're going to end up with a positive 2. But if we took 5 away from 3, we would end up with negative 2. So let's go ahead and subtract 3x from each side. So 5x minus 3x is 2x. The 3x's cancel each other. Bring down your negative 2 and your positive 4. We now have 2x minus 2 equals 4. Now let's go ahead and subtract 2 to get rid of the negative 2, or add 2 to get rid of the negative 2. And what we do to one side, we're going to do to the other. The negative 2 and the positive 2 cancel each other, leaving us with just 2x. 4 plus 2 is 6. Now let's go ahead and divide this 2x by 2 that we see in this line here. What we do to one side, we do to the other. The 2's cancel each other, leaving us with x. 6 divided by 2 is 3, therefore x equals 3. And we can always check our solutions by plugging it back in. So if you look here at this part here, there we go. Move that there we go. Cover that up real nice. If we look at this, we see we take this x equals 3. Then we take the equation here. You see it right here. 5x minus 2 equals 3x plus 4. Wherever there's an x, we're going to plug in that solution of 3. We do the math, and we find out 13 and 13. So indeed, both sides of the equation equals 13. So this checks out, and our solution is correct. Looking at the next page, to solve more complicated equations, you may need to first simplify by using the distributive property or combining like terms. So in example 2, simplify each side before solving equations. Solve each equation. Well, example A, we have 2 times the quantity of y plus 6 equals 3y. So let's go ahead and distribute that 2 in there. 2 times y we have here. 2 times 6 we have here. And bring down the 3y. 2 times y is 2y. 2 times 6 is 12. And again, bring down 3y. Now let's go ahead and determine, do we need to subtract 2 y's or subtract 3 y's? Well, if we subtract 2y, then the y's would cancel each other over here. And over here, subtracting 2y would still leave us a y. So it is positive. We're good to go there. So we end up with y. Bring down the 12, and we see that y indeed equals 12. And you could always plug that value of 12 back in on both sides for the value of y. Do the math and find out indeed they both equal 36 on each side of the equation. So the solution of y equals 12 is indeed correct. Looking at the next example, example B, 2k minus 5 equals 3 times the quantity of 1 minus 2k. So we're going to need to do some distributive property. Distribute that 3 into the quantity of 1 minus 2k. So let's bring down our 2k minus 5 on the left. We'll keep doing that all the way down through here. 3 times 1, we see that here. 3 times negative 2k, or they squeeze that in there. It's going to be negative 3 times 2k. It's going to be the same thing, either way you want to look at it. We're going to end up with a negative 6k. 3 times 1 is 3. Negative 3 times 2k is negative 6k, or minus 6k, either way. Now we have 2k's on the left, negative 6k on the right. Now this time, notice that this is a negative 6k. So if we added 6k to it, that would make the k on the left go away, and it would increase the value, the positive value of the 2k over here up to 8k. So in this case, we would rather add 6k's to each side rather than subtracting 2k from each side. So the negative 6k, positive 6k cancel each other, leaving us with 3 on the right. 2k plus 6k is 8k. Let's bring down that negative 5. Now we need to add 5 to get rid of the negative 5. What we do to one side, we do to the other. The 5's cancel each other, leaving us with 8k. 3 plus 5 is 8. I now have 8k equals 8. We now need to divide both sides by 8 so we can isolate this variable of k. Doing that on this line here. The 8's cancel each other, leaving us with k. 8 divided by 8 is 1. Therefore, k equals 1. Example C, looks like we're going to have to combine like terms on the left, and then we're going to have to use the distributive property over on the right. Then we're going to have terms of b on both sides, so we're going to have to collect or move the variables over to one side or the other, and then we can go ahead and get down to a 1 or 2 step equation from that point. So a little bit of work to do. Let's go ahead and start on that. So the first thing we need to do is, well, I would start from left to right and combine like terms, but they want us to go ahead and distribute first, so hey, let's do that. So all this left side here, 3 minus 5b plus 2b, they keep bringing that down all the way to this line. In the meantime, over on the right, they're doing the distributive property. So let's look at that. So we're going to distribute this negative 2 into positive 1 and negative b. So that's going to be this negative 2 here, just bring it down. Negative 2 times 1, we see that here. Negative 2 times negative b, we see that right here. Let's go ahead and do the multiplication there. So let's bring down our negative 2. Negative 2 times 1 is negative 2. Negative 2 times negative b, negative times negative is positive, so we get plus 2b. Now we can go ahead and combine some like terms. On the left, we have negative 5b and positive 2b's. So negative 5 plus 2 is negative 3, so we have negative 3b. And then negative 2 minus 2 equals negative 4. So we worked all this out to 3 minus 3b equals negative 4 plus 2b. So we have negative 3b on the left, positive 2b on the right. Well, if we subtracted 2b, then over on the left, this negative 3 is going to end up being negative 5, and we're going to have a negative value in front of our variable b. But if we add 3b to get rid of the negative 3b over here, then that's going to bring this 2b up to 5, and that's a positive number, so that would be more beneficial, or the preferred method of doing it. So we'll go ahead and do it that way. So let's add 3b to each side. Negative 3b plus 3b is going to eliminate the variable b on the left, leaving us with just this 3 here. And then adding 3b on the right gives us 5b, and we bring down to negative 4. So we now have 3 equals negative 4 plus 5b. Now let's go ahead and get rid of this negative 4 by adding 4. What we do to one side, we're going to do to the other. So these 4's going to cancel each other, leaving us with just the 5b, and 3 plus 4 is 7. Now I have 7 equals 5b. Let's divide both sides by 5 to get b, the variable b, by itself. And let's go ahead and do that. And then those cancel each other, leaving us with just b. And 7 over 5, if we simplify it to a decimal, is 1.4. All right, now we're going to talk about what is an identity. Remember, identity was our vocabulary word for this one. An identity is an equation that is always true, no matter what value is substituted for the variable. So no matter what number you plug in for x, pick any number. Positive number, negative number, rational number, irrational number, whatever number you plug in, it's going to produce a true statement. That is an identity. The solutions of an identity are all real numbers, as I was just saying. Some equations are always false. These equations have no solutions. So an identity has an indefinite number of solutions, or an infinite number of solutions, and a false statement, some equations that have no solutions. There are some equations that have no solutions whatsoever. So let's take a look at examples of those. First, let's look at the writing math. The solution set, for example, 3b is an empty set. It contains no elements. The empty set can be written as the circle with a 0 over it, or braces with nothing in between. Okay, so yeah, we'll get down here. That's, for example, b. So remember that whenever we get to b. So infinite many solutions or no solutions. Solve each equation. So we have x plus 4 minus 6x equals 6 minus 5x minus 2. Let's identify the like terms. So we can have a term of x here and here on the left. So 1x added to negative 6x is going to give us negative 5x. And then over here we have a couple constants. We have 6 and negative 2. 6 minus 2 is 4. So that brings us to this line. Now we have negative 5x and negative 5x. So let's go ahead and add 5x, get rid of the negative 5x, see what happens. And whenever we do that, the 5's on the x on the left is canceled, and the ones on the right are also canceled, and we end up with 4 equals 4. Well, this is a true statement. So if you go to try to isolate the variable, and in the process the variable just disappears and goes away, and you end up with a statement that is a true statement, some number equals some other number, in this case 4 equals 4, then that is an identity. There is an infinite number of solutions. So the equation x plus 4 minus 6x equals 6 minus 5x minus 2, it is an identity. All values of x will make the equation true, so all real numbers are solutions. Again, if you go to solve the problem, the variable just disappears, and you end up with some number equals itself, and it's a true statement, then that is an identity. Now example B, which is probably going to be a situation with no solutions, we'll see how that works. We have negative 8x plus 6 plus 9x equals negative 17 plus x. So let's identify our like terms. Negative 8x, positive 9x. Negative 8 plus positive 9 is positive 1, so we get 1x. bring down the 6. Now we have an x here, so let's go ahead and subtract x. What we do to one side, we do to the other. X minus x is no x's, they eliminate each other. Positive x, negative x, they eliminate each other. Bring down the 6, bring down the negative 17. And notice that we tried to solve this. The variables just kind of faded away and disappeared, and we end up with a false statement. 6 is not equal to negative 17. So the equation, negative 8x plus 6 plus 9x equals negative 17 plus x, it's always going to be false. Therefore, there is no value of x that will make the solution true. There are no solutions. So whenever it comes down to identity, infinite number of solutions, or no number of solutions, this is what we get whenever we try to work the problem out, find a solution. The variables just disappear, and we're left with just numbers on each side. If they equal one another, it's an identity, infinite number of solutions. If they don't equal each other, then it makes a false statement, and there are no solutions. Looking at example 4, consumer application, the long distance rates of 2 phone companies are shown in the table, over here at the table on the right. How long is a call that costs the same amount no matter which company is used? What is the cost of that call? So phone company A will charge you 36 cents plus 3 cents a minute. And company B charges 6 cents a minute. So with company A, no matter how long you talk, you're going to pay 36 cents, but then it only costs you 3 cents a minute. But with company B, it doesn't cost you anything to make the call initially, but for every minute you stay on the phone, it's twice as much as the other company. It's 6 cents per minute. So at what point are they the same? It says here, how long is a call that costs the same amount? So same lets us know down here, see this, an equal sign? Whenever they say this is the same as that, well, we can say, okay, this over here is the same as that over here. So let's go ahead and make a statement. We're going to let M represent minutes in our equation. We're going to write expressions for each company's cost. So on the left, we have company A, where when we have 36 cents is what we pay, plus 3 cents per minute. So we have 36 plus 3 cents, and the per minute is multiplication, and minutes is M, is the same as 6 cents per minute times the number of minutes. So 6M. So if we write all this out, 36 plus 3M equals 6M. We have that right here. Let's go ahead and consider which side should we collect our variables to. Well, if we subtract 3M from each side, then that's going to give us a positive M over here, 3M. But if we were to subtract 6M from each side, then we end up with a negative 3M over here. And we don't want to do that. We want it to keep it positive. So let's go ahead and subtract 3M. So we subtract 3M from each side. On the left, the 3M's are eliminated, and we just have the 36. 6 minus 3 is 3, so we have 3M on the right. Now divide both sides by 3. And that leaves us with just M. 36 divided by 3 is 12. Remember, 12, the answer represents the number of minutes, so it's 12 minutes. The charges will be the same for a 12-minute call using either phone service. Now to find the cost of this call, evaluate either expression for M equals 12. Now over here we have where we plug it in on this side here. Let's see, they have M. Yeah, here's the expression, then they plug it in, then they work it out and get 72. I'd probably use the shorter one over here, just 6M, so 6 times 12, right, would be 72. A lot easier than working out the longer side over here. So the cost of a 12-minute call for either company is 72 cents. That brings us to our guided practice, so let's pick a couple of these. Let's go ahead and do example 2. We have 2C minus 5, and this is going to equal C plus 4. So let's see, if I subtracted 2C from each side, I think I'm going to get a negative over here. So let's go ahead and subtract a C from each side here. So these C's will cancel each other out, leave me with just a 4 on the right. 2C minus 1C is going to leave me, well, 1C minus 5. Now let's go ahead and add 5 to each side, and those will cancel each other out. C equals 9 in this case. So in this case, C equals 9. Let's do another example. Let's take it to where a little more difficult one. Let's try maybe number 7 right here. Okay, so I have 3c minus 4c plus 1, and that's going to equal 5c plus 2 plus 3, plus 2 plus 3. Now I probably want to combine some like terms. I see I have terms of c over here, 3c, negative 4c. And over here I have a 2 and a 3. Those are constants. I could combine those. So let's go ahead and do that. 3 minus 4 is negative 1. So I could say negative 1c, but I don't think I want to do that. I think I'm just going to put negative c. And then plus 1 equals, and I have 5c over here, and then 2 plus 3 is 5. All right, now I could subtract 5c from each side to get rid of this 5c, but this would make the left side negative 6c. And I want to keep my coefficient of the variable positive if possible. So let's go ahead and add a c to each side, plus 1c. That's going to cancel those out, leave me with just 1 there. 5c plus 1c is going to be 6c plus 5. Now let's go ahead and subtract 5 from each side. Those will cancel, leave me with 6c. 1 minus 5 is negative 4. Was I done? Yeah, I'm not done yet. And then the next thing I need to do is divide each side by 6. So if I do that, negative 4 divided by 6, that would cancel that 6 there, and end up with just c. And I could simplify that to c equals negative, and let's divide them both by 2. 2 over 3. So c equals negative 2 over 3. And then maybe let's do identity. Let's find some of those ones that says, is it identity or not? I believe that that would be, let's just pick one here. Let's pick number 12 right there. 6y minus, or equals, 8 minus 9 plus 6y. Okay, so from there, let's combine these like terms. So 6y equals 8 minus 9 is negative 1 plus 6y. Now let's go ahead and subtract 6y from each side. Minus 6y. Those are going to cancel. Those are going to cancel. Whenever they cancel out, we have nothing over here. The number that represents nothing is 0. So we just can't leave it blank. We got to put something there. So we're going to put a 0. Negative 1. The y's just went away. So in this case, there is no solution. And just because I'm hoping that I can pick one that does have, let's try number 11. See how that works out. So we have 8x plus 6 minus 9x equals 2 minus x minus 15. So let's combine our like terms. 8x's, yeah, right. 8x's minus 9x's is negative 1x. And let's bring our plus 6 down. All right, combine those, bring down the plus 6. Now on the right over here, I have we'll pull this negative x right here. Yeah, this will work nice. Actually, I think it's going to be no solution. I'll double check here in just a moment. So now I have, bring down the negative x, right? Now I have 2 plus negative or minus 15, so that's going to be a negative 13. And now let's add x to each side, plus x. The x's will cancel each other, leave me with 6 on the left, negative 13 on the right, and it turns out to be this one here has no solution as well. Okay, I'm going to guess then 10, and why not? Let's go ahead and try it. Let's see if we can find one that has an infinite number of solutions. Let's try 10. Let's do 7x minus 4 equals negative 2x plus 1 plus 9x plus 1 plus 9x minus 5. Yep. 7x minus 4, negative 2x plus 1 plus 9x minus 5. I don't know if this is going to work out or not. This may be no solution also as I glance at it. So let's see. So let's, on the right here, we don't have anything, or left, we don't have anything to combine. So on the right, let's see. negative 2x. Oh, yeah, we're going to be good to go. Bet. Negative 2x and 9x is going to be 7x. You see it coming. And then 1 plus negative 5 is negative 4. Looky here. Same thing on each side. We already know it's an identity, but what the heck? Let's go ahead and keep going. So let's subtract 7 x's, because we're going to say, okay, we're trying to get our x's on one side. Those will cancel each other, leaving me with negative 4. And those will cancel each other, leaving me with negative 4. And indeed, negative 4 equals negative 4. So this one here is an identity. Identity. Whatever. There we go. Can't spell today. So, infinite number of solutions. All right. All right. So those are all my examples, or that's everything that I've got for textbook chapter 2, lesson 4, solving equations with variables on both sides. Thank you.